Hey guys, it's James. I'm back with another homework video. Today I'll be doing problem number 56. The resistor R in figure P18.56 dissipates 20 watts of power. Determine the value of R. Let's start this problem by looking at the diagram. We have the 75 volt battery here. Let's say that the amount of current that comes out over here is just I. And since we have resistors in parallel, some of the current will split up. So we'll call the amount of current that splits up here I1. And then the amount of current that goes down here is simply the total current minus that, which is I minus I1. So what do we also know? We also know that since we have a 75 volt battery, that even though after that this 5 ohm resistor won't use all the 75 volts, that still at this point here I will have 75 volts that'll be split up between the resistors here, and that throughout the entire circuit, after you go through all the resistors, you must use up all your 75 volts. So technically there'll be also 75 volts, but to make things simple, I'm just trying to say that we'll use up all of 75 volts at the end. So I say that because that means if I have 75 at the starting point here and 0 volts over here, that there is 75 volts that's being used up by all of these. So I can say that the amount of volts used up by these two resistors minus the amount of volts used up by this resistor equals 0. And the other way around, it both works. And so I know that V equals IR. So I can come up with an expression for how much volts is used here and an expression for how much volts is used here, and subtract those, and I'll get something that will equal to 0. So let's start off by doing just that. I have the current I1 multiplied by the resistor. Since they're in series, I can just write 40 plus R minus the amount of current multiplied by the 30 ohm resistor. This will equal 0. And I have 3 unknowns here, so I need another equation so I can solve this, solve a substitution and get something that makes sense. So what can my second equation be? Before we were counting, all the resistors, but for now, let's just count what's happening here. I know that the amount of volts here plus the amount of volts here will equal 75. So 75 minus the amount of volts used by these two will also equal 0. So I can say that 75 volts minus the amount of current coming to this 5 ohm battery, which is just I, multiplied by that 5 ohm resistor, minus the amount of current multiplied by the resistor will equal 0. Total amount of volts minus volts used by that resistor minus volts used by this resistor gives you 0. So I can I'm just going to start cleaning this up. I'll get 30I minus 30I1 minus 40I minus I1 equals R equals 0. I can continue cleaning that up. And so that's what I have for this currently. I'm also going to go ahead and clean this up. And then I'm going to multiply by -1 so I can get a cleaner statement. And so what I'm gonna do now is solve. Not technically I could solve for any variable and plug it, but for this substitution, I'm gonna solve for just I and plug it into here. You can pull out I1. So that's my expression for I. I can plug into here. Alright, after boring you with all that algebra, this is what we have. And that in itself isn't very helpful. But before we move on, let's just recap. I found the amount of volts used by these two resistors. And I found out that this minus that, the amount of volts used here will give you 0. And so I also found out that the amount of volts they use here plus here will equal 25. So you can take 75 minus those two. And with those two equations, you got this. And so we need to start thinking about what other things can we use to solve this, because before we had the variable I and now we are down to just two variables. That means if I have I and R and the problem told me that it dissipates 20 watts, I should be thinking about using a power equation. There we go, P equals IV. You can take a look at that beauty for a second. Let's get ready to work. So as I said, we need to start talking about in terms of power. So let's use P equals IV. And because I have I and they gave me power, we can do something with volts, because I know volts equals IR. So I can just plug that in there. So I can get power in terms of I and R. And since they give me 20 watts, and I know, everything else is in I and R, we could also do another set of simultaneous equations and narrow this down even further. So knowing this, the reason why I say I1 is because if we're talking about this resistor with it's just R, we're talking about the current I1 that's being used to power or that's being used by the resistor. If this was R instead, we'd be just using I minus I1. And since we're talking about this bulb, we're using current I1. And so in our power equation, we're using I1 squared R. Knowing that, let's solve for R. R equals the 20 watts over I1 squared. Now with this, we can plug it back into here. That will give us 310 I1 plus 7 I1 20 divided by I1 squared, all equal to 450. You can clean it up. And now we find that we have one of these filthy quadratics. My favorite way to solve this is just by graphing it. And once you graph it and find the zeros, you find that you have two results, 1 amp and 0.452 amps. That means we'll be getting two different resistance values for resistance for that, for R, I'm sure what I mean. We're just gonna plug these values for I back up here. So, 20 watts over 1 amp squared, that's just 20 ohms. So that's answer 1. Answer 2 is 20 watts divided by 0.452 amps squared, giving you 97.89 ohms or 98 ohms. That is how you solve this problem. You will have two values for resistance for that R. That's all I have for you.